Alright, KC10, last one for this review. Well, that made a big jump. Whoa, that was a big one. Okay, KC10, the unit circle. An angle in standard form with a measure of 285 lies in which quadrant? Well, if you remember the quadrants, 0, 90, 180, 270, 360. 285 is located right here in between 270 and 360. Therefore, that makes it quadrant 4. Or for those that don't know Roman numeral, quadrant 4. Next, find the exact value of 60 degrees. So we're doing sine. If you remember, sine stands for y. 60 degrees. Well, if you remember it, let's just, how would I possibly do the hand trick here? We'll just go with it. You go with, this will be your pinky. This will be your index finger, so that'll be 30. This will be the middle finger, that'll be 45. 60, your index finger, and then it'll be 90 degrees. Remember, it's going to equal the square root over 2. We're doing 60, so let's eliminate it. Sine represents the bottom, cosine represents the top values. How many do we have left? On the bottom, we have 3 of them, so therefore square root of 3 is equal to sine of 60. The formal way will be to make a right triangle. So we have the triangle here. This is 60 degrees. We know the radius is 1. So therefore, this has to be square root of 3 over 2. And this will be 1/2. We're looking for sine, so we're looking for opposite. So that'll be square root of 3 over 2 over your hypotenuse, with my hypotenuse is 1. Alright, so it'll be square root of 3 over 2. 40, convert 220 degrees to radians. So this one is 220 degrees times pi over 180. So that is saying 220 divided by 180 pi. Simplify the fraction. So 220 over 180 will be 11 over 9 pi, which a lot of people will write it as 11 pi over 9 for radians. Alright, 41. If cosine of theta is equal to square root of 3 over 2 in quadrant 4, calculate sine. So for this one, I like doing the triangle here. Quadrant 4, so it's located a right triangle in quadrant 4. So I'm going to just be a little bit more specific here. So this is theta. We don't know what actually we do know the radius is 2. Here it's a mystery. We don't know that, so I'll call that one negative y because we're going down. To be specific, that point will be square root of 3, because this is my adjacent, also known as x, comma, negative y. So we don't know what negative y is, so we need to figure that one out. To do so, Pythagorean theorem. Oh, by the way, I forgot, this is square root of 3 here. So the Pythagorean theorem, we have a squared plus b squared equals c squared. C squared being the hypotenuse across the right angle. Because of that, 2 is equal to c. So I have 2 squared here. A could be, square root of 3 could be a or b. So we just put square root of 3 here with the squared plus, we don't know, b squared. Which b squared turns out to be negative y squared. Okay, then from here, the square roots will cancel, so I'm going to zoom in first. They cancel, leaving me with, wait, did this just happen again? Okay, I'm going to just restart this, I guess. Wow. Okay, at least it wasn't deleted. Okay, so that cancels, leaving me with 3 plus, I'm going to put that in parentheses still, squared is equal to 4. Subtract 3, so I'm left with negative y squared is equal to 1. And then I need a square root them. It's leaving you with negative y is equal to 1. We want to take that away, so we just switch the signs to y is equal to negative 1. We need to find sine though, so I'm going to replace that with negative 1. We need to figure out sine, so remember sine is opposite over your hypotenuse. So sine of theta is equal to negative 1 over my hypotenuse becoming 2. Okay, 42. If sine of theta is equal to square root 2 in quadrant 2, calculate cosine of theta. Quadrant 2. So this is right triangle, theta, quadrant 2. So we have the hypotenuse being 2 right here. This will be square root of 2. So therefore, if I'm being technical, that point right here will be x, well, negative x, okay? Class, if you're watching, I apologize for the jumpiness of my softwares right now. So I'm going to make this quick, square root of 2, and make that point, okay? Because this is my h, that one was my y. We don't know what negative x is. So therefore this point, it's a mystery. It's negative x, comma, square root of 2. To solve for x, we do Pythagorean theorem again. Oh wow, so it's 9. 2 represents your hypotenuse, so that's going to equal 2 squared. We have square root of 2, so we have square root of 2 squared plus negative x squared. So I'm going to zoom in more. Now that we got the points, plus negative x squared. The square roots will cancel, leaving me with 2 plus negative x squared is equal to 4. Subtract 2 to both sides, leaving me with negative x squared is equal to 2. Square root both sides, then that'll be negative x is equal to square root of 2, but x is negative. Why? Because it's in the second quadrant. Just flip the sign, so x is equal to negative square root of 2. So I'm going to substitute negative square root of 2. We're looking for cosine, so cosine is your adjacent over your hypotenuse. So cosine of theta is equal to negative square root of 2 over 2. Okay, 43. Given the point negative 6, 8 on the terminal side of the angle, evaluate cosine. Alright, for this one, it's very similar to the previous problem. It's very similar. Just this time we're given the coordinate point. So the coordinate point is negative 6, positive 8. So that will be the second quadrant. So this point is negative 6, 8. Therefore, if I create a right triangle, negative 6 represents my x, and 8 represents my y. We don't know my hypotenuse. How do I figure out the hypotenuse? Pythagorean theorem. So we do negative 6 squared plus 8 squared is equal to 8 squared. That'll be 36 plus 64 is equal to 8 squared. That is 100 is equal to 8 squared. Square root both sides. H will equal 10. What was it asking us to solve? Zoom out a cosine. So cosine of theta is equal to x over your hypotenuse. Therefore, cosine of theta is equal to my x being negative 6 over 10. That could be simplified to negative 3 over 5. Wait, did that just happen again? Oh wow. We couldn't start 1-0 for last time try. What do I want to do? Let's just go with start normally. For once. Okay, I'm gonna just do this one quick. H equals 10. So that means cosine of theta is equal to negative 6 over 10. Maybe if I change the settings. Alright, 44. Given the equation y equals negative 3 sine of theta, identify the amplitude. Remember, the equation is y is equal to a cosine b theta plus k. A represents amplitude. So my amplitude is equal to 3. Well, I should be putting that symbol, absolute. So you always make it positive. Alright, not negative. So it's positive 3. 44. For problem 44. Alright, next one. 45. Given the graph, write the equation of a sine function. Okay, so here they told off the bat is a sine function. Why? Because we're starting at the origin. So therefore, since we're starting here at 0, this has to be the midline. So the k equal to 0. Then we need to figure out the amplitude. What's the amplitude from the midline? 1, 2, 3. So that was 3. Okay. Downward 1, 2, 3. 3 as well. So my amplitude was equal to 3. What I know so far is y is equal to 3 sine. After the midline, since I'm going up, that means it's going to be positive 3. If I was supposed to be going down instead, it would have been negative 3. But we have positive 3 in this case. Okay, so I have my A, my sine, and now I need to figure out B. B represents the first cycle. A sine function has this representation of it. Wait, that's, yeah. We start halfway, go up, there we go. This represents sine, the closest one. So up, down, midline, down, back to the midline. So this is identical to the first cycle. Then we look at where did we end up. We ended up at 2 pi. Since it was 2 pi, B represents the number of cycles from 0 to 2 pi. And we only had one cycle. Therefore, B has to equal 1. So we put 1 theta. And our midline was 0, so we don't have to write anything at the end. What is the period of the graph? Well, the period of graph means how long did it take. Remember the equation P is equal to 2 pi over B. What was my B? 2 pi over 1. Simplify that. 2 pi. (47) Write the equation of a trigonometric function with amplitude 2 and period pi over 2. Well, it could be equation, so it could be cosine or sine in this case. Since we haven't seen anything from cosine, let's just write a cosine equation. Y is equal to, my amplitude is 2, cosine, I don't have a midline, so therefore my midline, well, let's go with 0. But if my P is equal to pi over 2, I know P is equal to 2 pi over B. So I substitute on pi over 2 is equal to 2 pi over B. Cross multiply between with 4 pi is equal to pi over b. Divide both sides by pi. Pi will cancel. B is equal to 4. So we put a 4 theta, and that'll be it. We do not put a negative because it wasn't being reflected, and we don't put a number at the end because there was no midline. Right, and I guess that concludes KC10, and therefore end of the review. Good luck on the finals.